Here we have paper 2 from the 2019 higher exam, and I'm going to be focusing on question 7 here. Now this question looks at quadratics and cubics, the relationship in terms of factorizing and working with derivatives to demonstrate properties of graphs and functions themselves. So the first one's about looking at factorizing it into a set form. Second one is looking at properties of the function when it's strictly increasing, decreasing, and how to prove all of that. So we're going to start with this first one here. So express negative 6x squared plus 24x minus 25 in this format here. Now to do this one, what I would do first is focus on just this little section here. So if I focus on that, I've got negative 6x squared plus 24x. What I would do is I would take out the negative 6, so I then end up with x squared minus 4x. Now the reason being, if we look at the format that we want at the very end, we've got a term that's just x left on its own. So if I take out this whole of negative 6, I'm left with an x squared. When I factorize the x squared part, what I'll end up getting is just an x on its own. What I'm then going to do is factorize this bit here so it's in a format of x plus or minus something squared. So x squared minus 4x, what I'm going to do is write that as x minus 2 squared, because that is half of this. However, if we were to multiply x minus 2 squared, we get x squared minus 4x plus 4. So what we have to do is correct to get rid of that plus 4. So what I'm going to do is I'm going to take away 4 overall to get rid of that. Now remember, this whole thing here is in a bracket multiplied by the negative 6. This negative 6 hasn't had any form of an effect on it yet. What I'm then going to do is multiply out the bracket. So I'm then going to end up with negative 6 bracket x minus 2 squared. It's then going to be minus 4 times minus 6, so it's then going to be plus 24. Now if we look back to the original function, that's me dealt with this first part here. I haven't dealt with the minus 25. So what I'm then going to do is I'm going to take it up and I'm going to say fine. So negative 6x squared plus 24x minus the 25. That equals this bit here. So the minus 6 bracket x minus 2 squared plus 24. But then it's take away this 25 here, because we've not done anything with it up until that point, but it's still included in the function. Simplify the numbers here. What we end up getting is minus 6 bracket x minus 2 squared minus 1. So there you go. That's me factorised it into that form there. Now just be aware, I know it says plus q and plus r, but remember that could be plus the minus 2. So q here would be the minus 2. R here would be the minus 1, despite the fact that it says plus in both of those. Just be aware of that with the signs. Part B was looking at this cubic function here and talking about how we want to prove it's strictly decreasing. So whenever it talks about strictly increasing or decreasing a function, instantly think about the derivative. Remember, derivative discusses the rate of change. So for it strictly decreasing, what we want to show is that the derivative of the function is always less than 0. If it's always negative, then it's strictly decreasing. So what I'm going to do is I'm going to take the original function, which is given by this here, and I'm going to find the derivative. So I'm going to get f dashed of x, that equals negative 6x squared plus 24x, take away 25. So I've calculated my derivative. But look at this, lo and behold, this is the equivalent of that. So what I'm going to do is take this and write it in that format, because this will actually come in very handy when we do it. Because if I do negative 6 bracket x minus 2 squared minus 1, this here is easier to interpret than this in terms of the values of x. Because what I can say and what I know is that I've got this bit here, x minus 2 squared. Now, no matter what that is, a square number is always positive. So what that means is x minus 2 squared is always greater than 0. So what that means is if I look at this function here, what I'm going to get is a negative times a positive, which is always going to be a negative. So I've then got some number that's negative, take away another number. Now, even if x is equal to 0, I'm still going to get 0 here, but I'm still going to take away from it. So what I can then say is, therefore, based on that, f dash of x is always strictly less than 0. Because it's always strictly less than 0, we know that it's strictly decreasing. Okay, we know it's strictly decreasing. So we have to be able to communicate that clearly. Now, one thing I should probably have included here is this statement here where it says for all x. So x minus 2 squared is greater than 0 for all x. Whereas this one here then tells me that f dash of x is less than 0, so it's decreasing for all values of x. We have to be able to communicate that over clearly and get an idea over that we want. We have to be able to do it. Now, we could have done this one here with a sketch as well, but we'd have to make sure we annotated the diagram properly and that we worked it through correctly following the logic. Personally, use the derivative. Derivatives always relate to rates of change. Rates of change, increasing, decreasing values of functions. It's much easier and straightforward to relate them to one another and back to the scenario than it is any other way. So there we go. That's this type of question. Now, in terms of marks, part A is worth 3 marks. So first mark is given by taking out the -6. Second is here by getting the x minus 2 squared. And then the third is here, getting this final answer. Now this first one here could also have been done by expanding this bracket here. So there's another way we could have approached it. The second part here, B, again is also worth 3 marks. First mark for differentiating here. And this method here that I've used, second mark for substituting in and coming to this conclusion, that x minus 2 squared is greater than 0 for all x. Then the third one is communicating this final part where it's strictly less than 0, so it's decreasing for all values of x. It's not good enough to just write this and then write f dash x is less than 0. You have to state why it's less than 0. You have to show your understanding of the fact that x minus 2 squared is positive. Negative times a positive is always going to be negative, so you're always going to have a negative value. Remember, you can't just assume these things. You have to show, you have to communicate, you have to verbalize or write down your reasoning behind things. Show you know what you're going on about. Then they can't take anything away from you, and you're able to clearly and concisely communicate anything you want to through this question.